Hi everyone, welcome back to ANR Academy. Today we are going to discuss the proof of mode formula in statistics. Suppose in the given table, if you have set of observations and their set of frequencies, then we know that the most frequency variable is known as mode of the given data. In case class interval along with frequencies are given, then to find the mode of given data, we use the formula that is L plus F1 minus F0 whole divided by 2 times of F1 minus F0 minus F2 into H. And here capital L is lower limit of model class, H is width of the model class, and F0 that is preceding frequency of model class, F1 is frequency of model class, and F2 that is succeeding frequency of model class. And we can decide model class by the frequency, by the greater frequency which is appearing in the given table, right? So let us see why we are going to use this formula to find mode of given data in statistics. See here, there is a graph which indicates class intervals as well as frequencies. Here you have more frequency in this interval. This is known as model class. I am going to write here, this is actually model class, and for which this one is lower limit L, and this interval having maximum frequency. Why? Because here y-axis indicates frequency, x-axis indicates class interval. Now suppose that the greatest frequency in the given data, that is F1, maximum frequency it is F1, I am going to select. Next, the preceding frequency of model class, assume that this is some F0, and the succeeding frequency of the model class, that is F2. Just now we discussed model class which decides by the greater frequency. Yes, F1, F0, F2 also mentioned in the graph. And clearly whenever in the given data class interval is given, the value of mode which depends upon adjacent frequencies, that is F0 and F2, so that I am going to join maximum frequency with succeeding frequency and maximum frequency with preceding frequency. Depending upon these two, we get mode. Why? Because class interval is given. Now observe here, there are two triangles which are similar. Here it is very clear that these two lines are parallel. Therefore, these two angles are alternate angles equal. Next, here also these two are alternate, and you have vertically opposite angles also there. These two are vertically opposite. So now these two triangles are similar triangles. Assume that this is some A and this is B. Suppose it is C and it is D, and assume that the point of intersection, suppose P. So that from figure I can write Here triangle APB, it is similar to triangle DPC. These two triangles are similar, therefore I am going to write the condition here. AB is one of the sides of triangle APB, and the corresponding side in the next triangle you have CD here, that I am going to mention next. The ratio of sides AB, CD equal to the ratio of their heights I can write. Due to similar triangles, sides ratio equal to sides ratio proportionate as well as heights ratio also proportionate. Assume that this is of height h1 and the second triangle of height h2. First triangle is of height h1, second triangle is of height h2. Now AB, the difference I can express with frequencies f1 minus f0. I can write this one as f1 minus f0 divided by CD is the difference of the frequencies f1 minus f2. f1 minus f2 it is. Next, observe the figure, height of the triangle ABP. This is the height, right? We know that the value of mode, that is in between lower limit and upper limit of model class, and here if you drop a perpendicular, this is clearly mode of the given data. Mode is depending upon succeeding frequency as well as preceding frequency, and also depending upon the maximum frequency of model class. So here it is mode, and I can write height since it is origin from the result mode. If you remove lower limit part, then you will get height. 0 to L, the portion if I remove from O to M, OM is clearly mode of the given data minus from which we are going to remove lower limit. Lower limit is denoted by L notation. Next, H2. H2, that is height of the second triangle. This height that I am going to write. See, this height can be written as actually from B to D. This is known as width of the class interval. From the width of the class interval, if I remove from width of the class interval, I am going to remove this height, then you will get remaining height. Here in this case, clearly h width of the class interval equal to h1 plus h2, height of the first triangle plus height of the next triangle. But here the requirement is from h, if you remove h1, automatically you will get height of the second triangle. H minus h1 is clearly h2 in this case. So h2 written as h minus h1, but h1 you have in the numerator part, that is mode minus L. I am going to use the property of ratio proportion, that is, if suppose A by B equal to C by D, then by ratio proportion I can write A by A plus B, which is equal to C by C plus D. I am going to use this result now. Let us observe what happens. Numerator F1 minus F0 as it is, and here mode minus lower limit as it is. Next, I am going to add both numerator and denominator part, that is F1 minus F0 plus F1 minus F2, and here I am going to add both numerator and denominator part, mode minus L added by H minus mode minus L. Here mode minus L gets cancelled. This is F1 minus F0 whole divided by 2 times of F1 minus F0 minus F2, that can be written as mode minus L whole divided by H. In the next step I can write, on cross multiplication mode minus L can be written as H into F1 minus F0 divided by 2 times of F1 minus F0 minus F2. In the next step I can write the value of mode. So mode formula L plus H into F1 minus F0 divided by 2 F1 minus F0 minus F2, or you can write mode formula L plus F1 minus F0 divided by 2 times of F1 minus F0 minus F2 multiplied by H, where L is lower limit of the model class and H is width of the model class, and we can decide model class by seeing maximum frequency interval. Yes, next F0 is frequency given greater frequency of model class is F0, and F1, F2 they are clearly from the figure we already discussed. F0 is preceding frequency of model class, F2 is succeeding frequency of model class. So using this formula we can find mode of the given data. So this is the reason behind that. Blindly we follow to find mode the formula L plus F1 minus F0 by 2 times of F1 minus F2 minus F2 into H, but particularly this is the reason behind this. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.